In this exercise, we have a formula, and our duty is to prove that it is either a tautology or a contradiction. And we are supposed to prove this by using well-known logical laws. If you look at the formula, you can immediately see that it contains implications, and we already learned what to do with implications. We can eliminate them. So for instance, we can eliminate the first implication here by negating the left-hand side and replacing the implication with disjunction, right? Okay, let me just copy the rest of the formula like that. We have another implication here, and we can apply the same law. So we are going to replace it with disjunction and keep the right-hand side. And of course, we also have to negate the left-hand side. And let's not forget about that. Implication has lower precedence than this conjunction. So as a result, the entire formula here is the left-hand side of the implication. Therefore, you have to negate all that formula, right, like that. Okay, let's continue. And, well, what should we do next? Well, maybe this negation, which negates an entire compound formula. So this is interesting. Maybe this could be simplified somehow. And yeah, actually, this is the case. Exactly. To this case, there is a very, very well-known logical law which we are going to apply. So look at this formula here. Now we negate a conjunction, right? So we have negated conjunction, and let's just look for a law which can deal with such a negated conjunction. Here it is. This is one of the so-called De Morgan laws. If you have a negated conjunction, then you can translate it to a disjunction, and meanwhile you have to negate both operands, P and Q. So again, you flip the conjunction to disjunction and negate both operands. Let's do the same here. So here we flip the conjunction to disjunction and negate both operands. The first operand was inside those parentheses, right? The second operand is not Q, so we have to negate not Q. Therefore, a double negation appears here. Immediately, I want to show you that double negations can always be simplified out. Here you can see that. Therefore, we can remove the double negation here. Okay, and let's just copy the rest of the formula like that. Before continuing, we can do a very easy simplification here, because we have two disjunction with a parenthesis between, and as you know, disjunction is associative. I mean, associative, it means if you have disjunctions with some parentheses between, then basically, since it does not matter in what order you evaluate those disjunctions, you can eliminate those parentheses. Long story short, this is what we are going to do. So we are going to eliminate this pair of parentheses. Yeah, great. Let's now focus on this part. This is a negated disjunction. Yeah, you can guess it. So there is a De Morgan law which can be applied to such a situation. If you have a negated disjunction, you can turn it to a conjunction, but at the same time, do not forget to negate both operands. Okay, let's do it. So this part can be transformed to P and not Q. And let me just copy the rest of the formula, what's left. Okay, so now the formula looks quite promising. It's quite simple, but so far we don't know if it is a tautology or contradiction. Might be because it looks quite redundant. You can see P and not P in the formula, Q and not Q. So there's a high chance that you can simplify something out and finally you can get a simple formula which can be analyzed, and then you can see if it is a tautology or contradiction. So what's the situation here? I would like to highlight that we have a formula inside this pair of parentheses, and the formula has conjunction. So inside the parentheses, we have conjunction. Let's keep this in mind. And outside of the parentheses, you have disjunction. Well, I want to show you a very important law, which is called the law of distributivity. Law of distributivity, which focuses on similar situations. You can see here that inside this parenthesis we have conjunction, and outside of the parenthesis we have disjunction. This is the situation we are facing to. So what does this law do in this case? Well, it's interesting. It forms a pair out of P and Q, you see, and connects them with disjunction. And in a similar way, it forms another pair from P and R and connects them with disjunction. So basically, there are two pairs formed. And besides that, it is really interesting to see. Oh, it is really interesting to see that the operators are somehow flipped. So before applying this law, disjunction was outside of the parentheses, but it got inside, right? And in a similar fashion, conjunction was inside the parentheses and it somehow got outside. So they just flipped their location. Anyway, let's apply this law of distributivity here by forming pairs. Okay, the first pair can be formed like that. So we are going to form this pair and get P or Q or not P. And in a similar way, we are going to form another pair, not Q, with this guy. Not Q or not P. And I would like to highlight what I have just mentioned before, that the conjunction was inside the parentheses and now it's outside. And in a similar way, disjunction was outside and now it's inside the parentheses. So they flipped their location. They flipped their roles. Okay, how to continue? Well, now everything seems quite promising because inside those parentheses, we can find actually contradictory pairs of formulas. Let me show you what I'm talking about. Let me start with these guys. So now we have not Q or Q. And there is a law for such situations. Here you can see it. This is called the law of excluded middle. So whenever you stumble upon such a pair of contradictory pairs of formulas, so you can find a formula and its negation and they are connected with disjunction, you can just remove them and replace them with one. So this is what I'm going to do here. Replace this with one, and similarly I'm going to do the same here for P and not P or not Q. So what I'm going to get after that is the following: 1 or Q and 1 or not P, right? Almost done. Now that 1 appeared in the formula, there's a very, very high chance that we can do more simplifications, because we have this table has a bunch of formulas which are exactly for such situations. Here you can see them in the middle, those guys. Those are called the laws of identity and annulment. Anyway, now we are facing to this situation. In our formula, 1 is connected with something with disjunction between. So this means we can just simplify out the other guy. So we can just simplify out those guys. And finally we get, 1 and 1. Oh, it's not easy to see what is 1, what is conjunction. And of course, this can be further simplified to 1. Yeah, so this is the final result. We simplified the original formula to a single 1 value, which is very nice, very nicely done. And of course, considering regarding the original question, what have we proved? Is the original formula a tautology or a contradiction? Well, it's a tautology, of course. A tautology means it's always true, and as we can see, it is. Definitely it is.